The Milky Way, a supermassive black hole with a lot of stars around it and us. The Milky Way is the most important galaxy in the universe, mainly because it's the place where our solar system calls home. Today we are going to talk about the galaxy of which we know the most of. Today we are going to talk about the Milky Way. So what about the Milky Way? Why, besides the fact that we live in it, is it so important for us? Well, first and foremost, due to the fact above, it's the place in the universe where we have the best opportunity to observe cosmic objects up close, making it a vital tool to study stars, other planets, black holes, and a whole lot of other stuff that we find in space. Starting from the beginning, and I mean the real beginning, right after the Big Bang, the Milky Way started its life as a small, over-densely distribution of mass. Stars began to appear from the collapsing gases, and soon gathered into globular clusters at first, where the oldest stars are still found in the galaxy today, and after a few billion years of accretion of material and gathering of stars, the mass of the galaxy became so high that it started to spin relatively quickly, causing it to take its present spiral form from what was previously a sphere. Half of all the matter came from distant galaxies that now form a halo, and over time, growing through galactic mergers, especially in the first part of its life as it accreted gas and stars from smaller clusters nearby. A significant event that happened in our galaxy's past was the merger with a particularly large galaxy that happened around 11 billion years ago, that bear the ominous name of the Kraken. Being the only such merger that happened in the last 10 billion years, an unusual dynamic that you don't see very often with most galaxies, as mergers are a fairly common phenomenon across the cosmos between peer-to-peer galaxies. At this moment in time, the Milky Way is a G-type galaxy, a galaxy that produces fewer and fewer stars, with the exception of a small hiccup that will happen in around 3 to 4 billion years, when it will merge with the Andromeda galaxy, seeing a temporary spike in star production. But that won't last very long. Typically, a type of galaxy as our own stops producing stars in around 5 billion years, shifting its color from green, as it is now, to red as opposed to blue galaxies where star formation manages to occur violently with a very high frequency. In the present, our galaxy has between 100 to 400 billion stars, depending on the count, out of which 10 billion are white dwarfs and 1 billion neutron stars, with the oldest star ever discovered to be this thing, a tiny, ultra-metal-rich star made from material directly from the Big Bang, being 13.5 billion years old, followed by 1523-0901, a 13.2 billion year old star located in the galactic halo, with stars having an age of around 12.8 billion years in the bulge and 8.8 billion years on the thin disk, showing a gap of 5 billion years between the disk formation and the core bulge, when star formation slowed down due to the increase of temperatures of the cosmic gas. Along all of these stars, there are also 100 million black holes, and one supermassive engine black hole in the center of the galaxy, named Sagittarius A, with around 4100 solar masses, and by all counts is a dormant galactic center, not spewing too much radiation in the form of a stellar quasar. The total mass found in the galaxy lies between 890 and 1.54 trillion solar masses. Besides stars and black holes, we also find a lot of planets in the galaxy, with at least one planet per star. But most planets are not bound by any system, being cursed to wander the void of space, starless and lifeless. Nevertheless, in the galaxy there are still 17 billion up to 40 billion planets that are the size of Earth, orbiting the habitable zones of their parent star, with estimations that Earth-sized planets outnumber all of the gas giant planets in the galaxy. Out of all of these, 11 billion have a sun-like star as their parent star, and around 300 million are estimated to be habitable worlds. And besides stars, black holes, and planets, we find the building block for all things in the universe, in the form of cosmic gas, with an equivalent mass of 10 to 15% of the mass of all stars. This gas is made out of 90% hydrogen, with 2/3 atomic hydrogen and 1/4 molecular hydrogen, along with 10% helium and 1% cosmic dust. But 90% of the total mass is invisible, taking the form of dark matter, that has a great influence on the orbits of stars and on the orbits of the small and dwarf galaxies that are around the Milky Way, allowing the high velocities of these objects at the periphery of the galaxy without them being ejected and without changing their orbit, having a 2 million light-year dark matter disk that surrounds it. The Milky Way has a diameter of between 170,000 up to 200,000 light-years across, and possesses a thickness of around 1,000 light-years from top to bottom. Besides this, there is an additional ring-like filament of stars that ripple above and below the galactic plane with a diameter of between 150,000 to 180,000 light-years. A spherical halo made up from old stars and globular clusters, limited in size by the large and small Magellanic Clouds, with a 100,000 light-year radius, surrounds the galactic disk, with 40% of it orbiting in the opposite direction of the Milky Way's rotation, possessing gas so hot that star formation isn't possible here, unlike in the galactic disk. With the disk being further surrounded by a ring of galactic debris, resulted from the interaction with the Canis Majoris galaxy. Along this stellar halo, we also find a gaseous halo that is hundreds of light years in diameter, reaching the large and small Magellanic Clouds and having a total mass equivalent to the Milky Way, with the gas reaching temperatures of up to 2.5 million degrees Kelvin. The Milky Way is a spiral galaxy with loosely wound arms and is divided into 4 galactic quadrants, starting with the first one from the position of the solar system in the galaxy. It has 4 main arms that turn and branch into more smaller arms, with one of these smaller arms hosting our solar system. 2 of the 4 main arms is made out of old stars, while the other 2 have fewer stars and more cosmic gas and are a place where star formation is more frequent. At 10,000 light-years from the center of the galaxies, stars form a bulge, being a very densely populated area of the galaxy. And around this center, there are huge antimatter clouds that formed either from electrons or positrons that were generated by powerful X-ray radiation emitted from neutron stars that are paired in binary neutron star normal living star systems. This antimatter cloud is 10,000 light-years across and has a brightness of 10,000 suns, and although we know that these X-rays from the neutron stars help create it, how exactly that happens still remains a mystery for scientists. After 40,000 light-years from the galactic center, stars start to drastically decrease in density, and after 27,000 light-years, we find the Sun, orbiting the galactic center in the habitable zone of the galaxy in a low star-dense area where little radiation is found. It takes our Sun 240 million years to make a full rotation around the galaxy, orbiting the center in an elliptical fashion, passing up and down the galactic plane 2.7 times as it makes a full rotation. It orbits with a speed of around 220 km per second, covering 1 astronomical unit in 8 days and 1 light-year in around 1400 years. But the speed of objects varies across the galactic plane, like the limbs on a clock having a 210 km per second average speed, with the slowest speeds being found near the center, while the higher ones near the edge of the galaxy, at around 254 km per second, at the outermost edges. If not for dark matter, then these speeds would have greatly varied, being much lower around these edges. The Milky Way is orbited by a bunch of smaller galaxies, with 2 of them being small galaxies, while the rest being dwarf galaxies, with the smallest having around 500 light-years diameter, and the biggest having a mass of 2% of that of the Milky Way. Most of these structures form a very large disk that orbits the galaxy in the same direction, which is inexplicable because it was thought that dark matter would have made them orbit in random patterns. But nevertheless, all of these smaller galaxies will eventually end up being absorbed by the Milky Way, eventually clearing up all of our immediate surrounding of matter, gathering it all over time in one compact region of space that is our galaxy. At this moment in time, we are in the process of merger with the Virgo stellar stream, found at a distance of 40,000 light-years away, which produces a perpendicular collection of stars with the galaxy's arms. But these are all small mergers, more like absorptions compared to the sizes involved. As for peer-to-peer mergers, the only such merger that our galaxy will ever experience from now on in its life will happen in around 3 to 4 billion years, when it will start merging with our closest galactic neighbor, the Andromeda Galaxy, that is moving towards us with a speed of 140 kilometers per second and will form a new elliptical galaxy that scientists in the most lazy way possible named Milkdromeda. Taking the way out of the Milky Way and the N from Andromeda and uniting the rest together, people that work years on a project and dedicate their life to science couldn't find a better name for our future home than Milkdromeda. But until then, at this very moment in time, our galaxy, together with the Andromeda Galaxy, form a binary galactic system, which belongs to a group of 50 or more other galaxies called the local group, that is surrounded by a local void, that is part of a local sheet belonging to the Virgo supercluster, that is also surrounded by a number of other voids, which change their shape over time, resulting in a giant filament belonging to a superstructure called Laniakea. So try to wrap your head around that. And depending on these points of references, our galaxy is traveling at around 630 kilometers per second with respect to local frames of references, and 552 kilometers per second with respect to the CMB. At the moment, there are a lot of satellites in space that are trying to map out the galaxy, permitting us to better understand our surroundings and potentially proving useful in the future of space exploration. Besides the fact that we live in it and have sprung into life and consciousness in it, the Milky Way has proven one of the most useful tools humanity has at its disposal to better understand stars and the universe. It cannot be stressed enough how much the galaxy has helped us and is helping us to see how the cosmos works. The main reason for this being its proximity to us, being very hard at the moment to study objects in other galaxies, almost all that we know about interactions in space resulting from the study of our own galaxy. But in the meantime, more research needs to be done in order to better understand the universe and how it works, and most likely the Milky Way will further play an important role in that study. Okay. Thank you all for watching the video. I hope you enjoyed it, and until next time, take care.